Sometimes the most profound mysteries aren't locked away in ancient legends or buried beneath wild conspiracies. They wait quietly inside peer-reviewed journals. We often picture science as a fortress of certainty. Equations map the cosmos. Instruments measure it. Experiments confirm it. Yet, the closer we look, especially at the quantum, biological, and cognitive frontiers, the more reality itself seems to slip through our fingers, as though a higher intelligence designed it to remain just beyond our grasp. Today, most of us live beneath the wide umbrella of materialism, the conviction that everything is born from physical matter, particles, forces, and neurons firing in the brain. This view has shaped medicine, technology, and the rhythm of modern life. But what happens when science begins to expose cracks in that framework? This is not about pseudoscience or fanciful speculation. These are 5 carefully documented, rigorously tested phenomena examined by physicists, neuroscientists, and institutions at the forefront of research. Each discovery forces us to face an unsettling possibility. Our current models of time, space, perception, and even consciousness might be incomplete or profoundly mistaken. Some findings suggest that the mere act of observing can influence physical outcomes. Others reveal that belief alone can trigger measurable shifts in brain chemistry. Still others whisper that space and time, the very fabric of reality, are not as solid as we once assumed. And perhaps most provocative, there are cases where consciousness appears to persist beyond the activity of the brain itself. This journey isn't only about physics or neuroscience. It's about the outer edge of what we dare to call reality, peeling back the surface of the known to glimpse something deeper, something participatory, interconnected, and perhaps guided by a supreme, intelligent presence. If you've ever sensed that life holds more than textbooks or talk shows admit, you're not alone. The evidence already surrounds us, and it's more mysterious than we've been led to believe. Welcome to Quantum Align, where we explore the scientific edge of the unknown. If you're drawn to profound questions and credible mysteries, gently tap that like button and subscribe. Your curiosity belongs here. Let's begin with an experiment so baffling even Einstein called it spooky. It starts with a single particle and a choice to observe. A beam of electrons is fired toward a metal plate with 2 slits. On the other side, a detection screen waits to record where each particle lands. With both slits open and no measurement in place, the electrons create an interference pattern, a wave-like design implying that each particle travels through both slits simultaneously. But when detectors are added to reveal which slit the electron passes through, the pattern disappears. The electron behaves like a particle, not a wave. Observation alone changes the outcome. This isn't a fluke. It's the famous double-slit experiment, one of the most replicated results in physics. Whether with photons, electrons, or even large molecules, the conclusion stands. The very act of measurement collapses a range of possibilities into a single event. The implications reach far beyond the lab. In classical physics, observation merely uncovers what already exists. In quantum mechanics, it may help define what becomes real. The Copenhagen interpretation, long dominant, suggests that reality exists in a state of superposition until measured. Competing views like many worlds propose that all outcomes occur in parallel, but only one becomes visible to us. In 1998, researchers at the Weizmann Institute pushed the idea further. By fine-tuning the degree of observation, they demonstrated that the more precisely a particle is measured, the more the interference pattern fades. At this scale, reality itself becomes harder to pin down the closer we look, as if creation hides its deepest mechanisms behind a veil, hinting at an order beyond random chance. This is no idle theory. It forms the backbone of quantum computing, tunneling, and modern electronics. And yet, it carries a philosophical weight. The smallest building blocks of matter, refuse to act as fixed entities until interacted with. The observer matters, not symbolically, but functionally. No one agrees on what exactly causes the shift. Is it consciousness, the act of measurement, or some deeper process not yet revealed? The data simply shows that the universe responds differently depending on whether it is being watched, inviting the question of whether a higher mind designed a cosmos that awakens only in relationship. Such possibilities rattle the very foundations of strict materialism. They hint that mind and matter might be woven together in ways we barely comprehend. Placebos were originally meant to be neutral, a control mechanism to separate real drug effects from psychological noise. But the data kept pointing to something else. Sugar pills, saline injections, even sham surgeries have triggered measurable improvements in conditions like chronic pain, depression, and Parkinson's disease. This isn't mere anecdote. Brain scans reveal that when a person expects relief, the brain releases natural opioids. In pain studies, fMRI images show activation of the same neural pathways that morphine stimulates, without any active drug present. In one experiment, Parkinson's patients who received a placebo displayed increased dopamine production, leading to visible improvements in motor control. The treatment was fake. The response was real. This is far more than the power of positive thinking. It is consciousness interacting with biology, belief igniting biochemistry, expectation shaping perception, the body preparing to meet the mind halfway. The implications reach far beyond medicine. For generations, materialist science treated consciousness as a passive byproduct of the brain, a shadow cast by neurons. But if belief can reshape brain function and body chemistry, the dynamic is not one way. It is a loop, a living conversation between mind and matter, perhaps even a faint reflection of the dialogue between creation and the infinite source that sustains it all. Stay curious with Quantum Aligned as we continue. If these revelations spark wonder, share this journey. Like and subscribe so we can keep exploring together the boundless intelligence woven through reality itself. The placebo effect is no fragile illusion. It can rival real medication in measurable power, especially in conditions tied to perception and regulation, pain, anxiety, even immune response. And it scales with context. A confident doctor, the crisp authority of a white coat, the comfort of a familiar setting, each element amplifies the effect. The brain responds not simply to chemicals, but to meaning itself, as though it recognizes an unseen order behind the symbols of care. None of this replaces medical treatment, but it quietly dismantles the idea that physical matter alone drives healing. The placebo reveals that the mind is never a passive spectator. It participates. If physics has shown that observation shapes the behavior of particles, placebo research shows that belief shapes biology. It is the observer effect turned inward. And just as belief bends biology, time itself proves to be far more flexible than most of us were taught. Every day, satellites orbiting Earth send signals to your phone. Without correction, GPS readings would drift by kilometers daily. The reason? Time moves slightly faster for those satellites than it does for you. This isn't malfunction. It's relativity in action. According to Einstein's theory, time passes at different rates depending on gravity and motion. Clocks in orbit tick a bit faster than clocks on the ground. The effect is small but measurable, and it must be corrected constantly to keep our technology accurate. Even more dramatic is the famous twin paradox. One twin travels through space at near light speed while the other remains on Earth. When the traveler returns, they have aged less. Experiments with atomic clocks on high-speed planes confirm it. Time isn't fixed, it bends. We tend to think of time as a neutral backdrop, moving forward identically for everyone. Relativity proves otherwise. Time depends on where you are and how fast you're moving. Two events can be simultaneous in one frame and separated in another. Duration itself becomes relative. This reshapes more than physics equations. It shakes the very structure of experience. If time can speed up or slow down depending on context, then what we call now isn't universal. It depends on perspective. Even sequence, the order of events, can shift with velocity and gravity. Some physicists even propose that time is not flowing at all. Past, present, and future may coexist in a larger design where consciousness travels through a fixed geometry. The idea remains debated, but the data is unambiguous. Time is not absolute. Physics can describe how time behaves, yet it cannot say why it passes or why our awareness moves through it in one direction. Some connect time zero to entropy, others to hidden quantum processes. But none fully explain the intimate, subjective experience of time or the reason it unfolds as it does. Our clocks still tick. Our schedules still move moment to moment. Yet beneath that everyday rhythm lies something far stranger, a system where duration, simultaneity, and flow depend on motion and mass. And if time can bend so dramatically under the right conditions, perhaps space itself is not the only thing that yields. Perhaps separation itself is more illusion than law, hinting at a unity that a greater mind intended from the start. In the early 1980s, physicist Alain Aspect carried out a landmark experiment in France. Two particles were entangled, prepared so that measuring one would instantly reveal the state of the other, no matter how far apart they were. The measurements were taken rapidly and at distances that prevented any signal from passing between them, even at light speed. Still, the particles behaved as one. This confirmed predictions made decades earlier by physicist John Bell. Bell had shown that quantum mechanics allows for correlations between particles that classical physics cannot explain. Aspect's team proved those correlations are real. Later, Anton Zeilinger's group expanded the tests, linking entangled particles across city-wide distances. Each time the results held. These are not faint signals or statistical quirks. The correlations violate what are called Bell's inequalities, mathematical limits on how much two distant particles should coordinate if they operate independently. Entangled particles break those limits. This does not mean information travels faster than light. It means our ordinary concept of distance no longer applies. Entangled particles don't communicate. They exist as parts of a single, unified system, even when separated by miles. The implications are profound. Locality, the idea that objects are only influenced by their immediate surroundings, no longer holds at the quantum level. Neither does the notion that particles have definite properties independent of measurement. Some theorists suggest that entanglement points to a deeper layer of reality, one where space and time are not fundamental but emerge from more basic relationships. In this view, particles are not isolated things but expressions of a shared state, a reality that seems to echo the oneness of all creation in the mind of God. This is no fringe speculation. It earned Aspect, Zeilinger, and John Clauser the 2022 Nobel Prize in Physics. Entanglement now fuels advances in quantum encryption, data teleportation, and ultra-secure communication networks. Yet the core mystery remains. Entanglement defies separation. It connects across distance without signal, disrupts familiar cause and effect, and refuses to fit into any conventional model of how the universe should behave. It is one thing to read about this in a textbook. It is another to realize these connections may not be confined to the quantum realm. Some researchers wonder if the principle extends to us, not merely as metaphor, but in essence. Because in rare and carefully documented moments, people separated from their physical bodies have reported awareness unbound by time or space. And in some of those cases, the accounts resist every conventional explanation. In 1991, for example, Pam Reynolds underwent a surgical procedure that required her heart to be stopped and her brain activity brought to zero. During this state, no heartbeat, no respiration, a completely flat EG, her consciousness seemed to persist. Stay tuned with Quantum Aligned as we journey deeper into these mysteries. If the idea of a reality woven together by a higher intelligence resonates with you, remember to like and subscribe so this exploration of the unseen fabric of existence continues to reach curious minds like yours. She later described vivid perceptions, the exact surgical tools used, conversations among the surgeons, and precise details that were later independently confirmed. Cases like this have been documented in peer-reviewed research. One of the largest, the ARE study led by Dr. Sam Parnia, investigated cardiac arrest survivors across multiple hospitals. Some patients reported awareness during periods when brain function should have been completely absent. A few even described verifiable details from their surroundings, details they could not have physically perceived. Neuroscience continues to wrestle with these reports. After only 10 to 20 seconds without oxygen, measurable brain activity ceases. Standard models insist that consciousness should vanish almost instantly. Yet some of the clearest, most structured experiences occur when the brain appears entirely offline. These experiences share remarkable consistency, a profound sense of detachment, an intense clarity, a panoramic review of life, and often a sense of presence, an encounter that many describe as unmistakably real. These moments are not hazy dreams. They are often reported as more vivid and convincing than waking life itself. Explanations involving low oxygen, sudden neurotransmitter surges, or hallucinations account for part of the picture, but fail to explain the verifiable elements, especially when accurate details are recalled during flatline conditions. These cases do not prove that consciousness survives death. Yet they raise urgent questions about where consciousness originates and whether it depends entirely on the brain. For decades, science has mapped neural patterns tied to emotion, memory, and perception. But none of this explains why we experience anything at all. The patterns are observable. The inner feeling that accompanies them remains a mystery. Near-death accounts shine a bright light on that gap. If awareness can persist when measurable brain activity is absent, then the model of consciousness is merely a byproduct of neurons begins to crumble. Some researchers propose that consciousness may be a fundamental property of the universe, like space, time, or mass. Not something produced by matter, but something present alongside it, woven into the very architecture of reality. We need not turn to dogma to recognize what the data quietly suggests, that consciousness is deeper, more intricate, and far less confined than once believed. And when we set these findings next to particles that respond to observation, biology that reacts to belief, and space-time that bends with perspective, a striking pattern emerges. These accounts become more than isolated anomalies. They form a single, ongoing mystery. Across every discipline we have explored in this journey, from physics to medicine to neuroscience, real experiments conducted under the most rigorous conditions keep pointing towards something that conventional models cannot fully contain. Particles that shift their behavior when observed. Brains that release healing chemistry when belief takes hold. Time that bends depending on where you stand. Connections that persist across distance with no physical link. And conscious awareness that sometimes continues when the brain is clinically still. None of these findings provide a final, tidy explanation. They don't hand us easy answers. Instead, they challenge us to release the notion that reality is settled, singular, and purely material. They call us to a wider understanding, one that respects scientific precision yet leaves room for mystery. Science is not failing. It is evolving. And as it does, the boundary between observer and observed grows ever thinner. The universe begins to look less like a passive stage and more like a living, participatory field, alive with feedback, relationship, and meaning. Whether you name that source the mind of God or the intelligence of creation itself, the evidence hints that we are part of something immeasurably larger. You don't have to sign on to any belief system to sense the weight of this. These results are not mere speculation. They have been published, replicated, and debated by some of the world's most respected researchers. What they suggest is not the end of science, but the beginning of a more expansive inquiry. If this kind of exploration stirs both your reason and your wonder, you're exactly where you belong. Quantum Aligned exists for those who value evidence and awe in equal measure. So if you haven't already, gently tap like and subscribe, and keep questioning not only what reality is, but how much of it we have yet to truly see.